All right, so we got these problems here, and our goal, of course, is to solve them, and that's pretty much what chapter 5 was all about. If I give you some big polynomial, can you factor it? Can you get it down to something? And can you eventually figure out what all the answers are? So number one is x cubed. This is a cubic thing, so right away you should think there are 3 answers, okay? But it's equal to negative 27. The first step always is to get it equal to 0. I don't care if it's by graphing. I don't care if you're factoring. I don't care what you're doing. None of this work is useful if it's not equal to 0. So you do that. Now, you can always fall back on the old strategy of graphing things and finding zeros, and hopefully that works, but not always. Sometimes it doesn't. So you kind of want to be, at least on some basics, okay with these 3 formulas up here. Difference of squares, sum of cubes, and difference of cubes. Now, this is a sum of cubes. If you see 2 things and one's cubed, you probably think it's a sum of cubes. In fact, when I give you the number 27, if you look over there, 27 is a perfect cube. So it's like screaming at you that this is a difference of cubes. So we're going to factor it as such. So if I think of the 27 as 3 cubed, and obviously x cubed is x cubed, and I go over here to my sum of cubes formula, it says a cubed plus b cubed is this stuff. So a would be x in our situation, and b would be 3. So plug it in here. We have a plus b, which is x plus 3, times this thing right here, which is a squared, and a was x, so x squared, minus their product, and 3 times x is 3x, and then plus the b thing squared, and b was 3, and 3 squared is 9. That is a lot faster than going to my calculator and looking for zeros. That would have worked, though, because if you'd graphed it, can you tell me just by looking at this what would have been a 0 if you'd graphed it? Should. What makes that 0? -3. If you'd graphed it, you would have seen -3 is a 0. You could have done the original thing divided by x plus 3. You would have got this. It would have worked out that way fine, too. But I think that was a lot faster. So really, these are for speed and to get you out of jam when it doesn't work. Well, like we just said, if you had graphed it, you would have seen one of the answers is -3. So that factor, x plus 3, has an answer of -3. This is a 3rd degree. The other 2 are inside this quadratic. So we're going to have to either factor this or do a quadratic formula. I don't think it factors. So don't spend forever trying to factor something. If it doesn't work, it's a quadratic. That's exactly why we have the quadratic formula. X equals -b. That'd be +3. Plus or minus the square root of b squared, and -3 squared is 9, minus 4ac. A is 1. I'm not going to write times 1 ever anymore. It's just getting old. So 4 times 1 times c, which is 9. So there's a 4 times a 9. And all over 2a, 2 times 1, which is 2. So you go work on that discriminant and clean that thing up. 9 minus 4 times 9, do PEMDAS. 4 times 9 first is 36. And 9 minus 36 is -27. And you should know what to do when you have a negative under your root by now. That just becomes an I thing. So a -27 under your root is a +27 under the root with an I outside. And that's a good answer. But we should always try to clean as much as we can. It's a square root of 27. So I should stop and ask myself for a second, are there any perfect squares that go into 27? And yes, 9 does. So I can do a little bit better. We can break the 27 up into a 9 and a 3. So I can write that as the square root of 9 and the square root of 3. And the square root of 9 is pretty. That's why we're doing this. It's just 3. So the final answer is 3 plus or minus 3 root 3 over 2, I over 2. And there's nothing else we can do. Nothing reduces. There's 3's on top and a 2 on bottom. They don't have anything in common. I can't reduce anymore. So there's all 3 answers. -3, 3 plus 3 square root of 3i over 2, and 3 minus 3 square root of 3i all over 2. And that's it. Okay, so break it down. Question?
What would happen if you just substitute x for -3 in the other equation?
Which one? This one?
Second, or,
here?
Yeah, right there.
I have no idea. This one, since its zeros are this, if I plug in any other numbers besides those, I can't predict what it's going to be. It's not going to be 0, but it's going to be something. If I plug in, I mean, it's just be some random number. -3 squared is 9, right? Minus 3 times -3 is -9. So I'm subtracting -9, adding 9, and then another 9. So for that particular number, it turned out to be 27, but it has no meaning, you know. So you don't plug in things and other things that aren't related. You'll get some number out, but it won't tell you anything. It's just plugging it in. You could have just done long division the whole way that way. Yep. But once in a while, you do have something you can't start with. If you graph it and there is no 0, well, you certainly can't, use our method for that. Or if you do graph it, it crosses some weird decimal that you don't know what it is, and that's all you got to go on. Well, you're kind of screwed there too. All right, number 2, little different. It's kind of factored and kind of not. Number 2 starts off with a 4x minus 3 cubed. And that is times an x cubed minus 3x squared plus 8x minus 24. So it started to be factored. They didn't just give you a big old long thing and say, go at it, but they did start to factor it. They got a 4x minus 3 cubed. Now this one in front is already factored. You can't factor 4x minus 3 down anymore, right? That's about all you can do. And for ones like this where it's not obvious what makes it 0, just set it equal to 0. Do a couple lines, don't try to do it in your mind. Number one thing I've seen people mess up usually is they think, when is this 0? And they try to solve it in their head and they get it all wrong. It's just a couple quick step equations. Algebra 1 stuff, just moving things around, dividing by a number, no big deal, 2-step equation. The answer to that one's 3/4. So that one 0 is 3/4. And over here with the cube, well, that's a separate beast altogether. So how am I going to find this thing's zeros? Well, this is like a new problem in 1. You got options. You can go graph this thing, see when some zeros are, do factors and all that stuff. But I think I got a faster way. For this one, I think that this could be factored by grouping, actually. Grouping is another technique to consider sometimes to make your life faster. If you have an even number of things, you can split them into 2 even groups. Maybe you can factor something out of the front and the back too, that they have in common. Well, let's see. The first group, you can factor an x squared out of both of them. And the second group, if I want this to work out, I want to have something in common with the first group. So I want this either have an x squared or an x minus 3 in it. And guess what? If you factor an 8 out, there's a x minus 3. So this thing is going to be factorable. They both have an x minus 3 in them, so you can factor that out, leaving you with an x squared plus 8. So that cubic factors down into this. And I bet that scares a lot of you, right? Like, I wouldn't have thought to do that. That's okay. If you hadn't thought to do that, guess what you could have done? You could have graphed this, right? Can you guess what 0 you would have seen? 3. You could have taken this divided by x minus 3. Guess what your answer would have been? That right there. So it's just a little faster than doing all that graphing stuff. But looking at this, one of the answers is therefore 3 from that factor, the x minus 3. And the other 2 are inside that quadratic. Yes, ma'am.
I'm confused how you got the x equals 3/4, but how'd you get rid of the cube?
Oh, well, this is just, what's the cube mean? It's there. How many times? 3, right?
So that'd be 3.
So for each one of them, what's the answer?
So then how do you have 4 answers?
Well, this is the ones where it's the same answer 3 times. So I do have 3 answers from this cubed thing. They just happen to all be the exact same
So you have 3 for the other thing?
this is a cube too. Yeah, so there'll be 3 answers. Yep. And we got 1 so far, but the other 2 are in this quadratic, right? Okay, so this one, we're going to finish it up. X squared plus 8 equals 0. So x squared is negative 8. And when you take the square root of that, it's a negative. Don't forget your plus or minus. It's an I. And you can clean up square root of 8 just a tad because there is a perfect square that goes into 8. 4 does. So we can call 8 4 times 2. Because the square root of 4 is pretty, it's 2. So the final answer for that one is 2 square root of 2i. And if you look at this fresh again, do you know what degree this whole thing was? Remember that trick yesterday for the factored form? What's this thing kind of look like if you ignore everything but the leading people? It looks like an x cubed thing times an x cubed thing, which is an x to the 6th thing. So I should have 6 answers. Are there 6? Yeah, there were 3 in this one, correct? And they just all happen to be the same thing. And over here, there was another 3, this one and Those two. So there is a grand total of 6. You don't need to write the same thing 3 times, though. So if you just left your answer as this, I mean, I'm fine with it because this one's here 3 times. So it looks like there's 4 answers, but there's not. That one over there is repeated 3 times, which is the bloody point. Good questions today. All right, let's do 3 now, finish it up. Then we'll get our review going and be done. Same deal on 3. It's a factored form. Kind of starts off partially factored for you. You have an x plus square root of 2. That's raised to the 5th power. How many x plus square root of 2's is that? That's 5, right? So they'll have 5 of the exact same answers. After that, they have another factor, x squared plus x plus 5. And after that, you got one last one, x to the 4th minus 3x squared. And it says a minus 2 on the board, but I'm going to change that to a plus 2 to make your life easy. How about that? Yeah. It's going to be 11 answers for this one. Very good. This is a 5th degree, correct? Ignore it. This is an x to the 5th. This is an x to the 2nd. That's an x to the 7th. And x to the 7th plus an x to the 4th times x to the 4th would be x to the 11th. Outstanding. Yeah. All right, let's get ready. We got 11 answers to find. Well, this one's already factored. So again, no matter how weird it looks, all you're trying to do is figure out when the factor is equal to 0. And you're used to that with normal numbers. If it said x plus 7, you'd immediately say negative 7. If it was x plus 16, you'd say negative 16. Well, if it's x plus square root of 2, then the answer is negative square root of 2. Because all you're doing is setting equal to 0, move to the side. How many of those are there? There's 5. So we just got 5 of the 11. That was easy. Where's the other 6? There's 2 in here and 4 in there. Now, this is just a quadratic in this term, right? So it's pretty easy to solve that. We can either factor or do quadratic formula. I don't think it factors. So for this piece, let's go do the quadratic formula and figure when that's 0. Negative b plus or minus the square root of b squared minus 4ac. 4 times 1 times 5 is 20. All over 2a. And there's really not a lot we can do with this one. Under the root's a negative 19. So that turns into a square root of 19i. And 19's prime. Nothing goes into 19. There's no perfect squares or anything that goes into 19. So I can't clean it up. I can't reduce anything. That's about as good as it's going to get. So now we got 5 answers from this term. We got 2 answers from that. We got 7 so far. The other 4 are in this 4th degree. So we're going to look at this fresh and ask ourselves, how can I factor that? Anybody recognize what this is? Outstanding. So let's factor this really quickly. Not in terms of x's, but what squared is x to the 4th? Very good. You guys are great at this. So we're going to factor this into an x squared, another x squared thing. But the normal thing works for quadratics. I got to think of 2 numbers that multiply to be 2 and add to be negative 3. And I think those answers are negative 2 and negative 1. So we're factoring that down. And now the 4 answers are split into 2 groups. There's 2 here and 2 here. These are going to be pretty straightforward from here. If x squared minus 2 is 0, then of course, we've done this about 1,000 times recently. You just move the number over and take a square root, right? So 2 of your answers are plus or minus square root of 2, which happens to be one of the ones over here. Just a coincidence. It's okay. You have a repeated one there and there, whatever. And this one, well, if x squared minus 1 is 0, then x squared is 1. And if you take a square root of 1, it's just 1. Don't forget your plus or minus. So the 2 other answers are plus or minus 1. And notice we have all 11. Doesn't look like 11. 1, 2, 3, 4, 5, 6, plus 5 of those, right? What's square root of 1? It's pretty. Square root of 1's 1. Yeah. So yeah, simplify your square roots of 1s and things like that. Simplify your square roots of 4. You got it. Very good. All right, let's do some LGs and get ourselves going with the rest of the review. You may. LGs. Unit 5. Unit 5. So we reviewed Unit 4 yesterday, Unit 5 today. Review assignments out there due tomorrow. Hopefully you're making some good progress on that and staying up with the pacing suggested.
Wait, how do I find what the degree is?
For which one?
On the
What's the degree mean? If you don't know what the word means, you can't do it. Degree literally means the biggest exponent, so it's the biggest exponent. Okay, 5.5. Get those out to your review packets. We're, of course, going to do a few problems together as we go. We'll be starting on number 16 today. 16 to the end of the packet is what we're going to be focused on. Nothing else really on your plate. Should have turned in your homework yesterday. If you turn it online, I haven't got a chance to grade those yet, but I'm working on it. Same with all the rest of y'all. Review packet for tomorrow. Let's do this. Here we go. Finishing up our review. We are doing Unit 5 today. Polynomial equations. Here we go. In a nutshell, the first section was really stupid. The first section was solving by graphing. What do you do when you solve by graphing? You get it equal to, you always do that, right? No matter what you're doing, you get it equal to 0. You graph it, and you just use your calculator to find the answers, okay? You don't have to be exact. They don't have to be perfect. You just graph it and see what the heck it is, and that's all. If they ask you for extrema, you can find those. If they ask you for zeros, you can find those. You can find anything you wanted with graphing, and that was the entire first section. So we'll do one real quick. There's only 2 of them, 16 and 17. Let's do 17. Now 17 looks really scary. There's a reason I'm putting all these fractions in here. It's not because I'm trying to just freak you out with fractions. The reason I'm putting the fractions is because I'm trying to make the window okay for you, so when you graph it, it'll just show up. You don't have to go hunt and change your window and all that stuff and all that nonsense. But it doesn't really matter if there's fractions or not, because you're graphing it, right? You don't have to think. You just got to move everything to one side and plug it in your calculator and you're fine. So moving things to one side, probably faster to move these over to the left. Would you agree? Quicker to move 2 things than 3 things. So let's do that. So we're going to have a 1/50th x to the 4th still chilling. If you move this one over, now it's a -100th x cubed. So I moved the x cubed over. I'm writing things in order too as I go. There's still an x squared, -3/5 x squared. And if you move the -1/4 over, it's a +1/4. So just move those 2 over. And you know what to do. Looks like you're already ahead of me. Great for you. Got your calculators out, looking good. Plug it all in. All you're trying to do is figure out the zeros. That's the whole point of solving by graphing, right? There is a graph provided. So you do need to kind of give me a rough sketch of what this thing looks like. And I have no idea. Please don't make me think. There's a bunch of slots over here for your answers. At the most, how many slots would you need for this 4th degree problem? At most 4. Yep. And all you're doing is look at the graph. You don't need to do any actual work. Just look at the graph and tell me where it crosses. Any places where it crosses? -5, a nice clean one. Sweet. Anything else?
-2.
Sweet.
5.
Oh, is that it?
There's 1 more.
Do any of them bounce?
No.
Well, there's either 1 more or there's either 2 more or 0 more. I'll tell you what, there's not going to be 1. Then don't ask me why I know that. So if I had to guess, there's got to be 1 more. Oh, this is a 4th degree. I'm an idiot.
There's 2.5.
A 2.5. Okay. And this normally I wouldn't want decimals, but for solving by graphing, it's totally okay. So wherever you get's fine. So there's that. Now I can, based on what you just told me, I bet I know what this graph looks like. Because you should also know at -5, it's going to cross. At -2, it's going to cross. At 2.5, it's going to cross. And at +5, it's going to cross. Plus, I know that this is a 4th degree that opens up on both sides. Yep. So I bet you it's going to go right like this. Is that roughly what your graph looked like? Ish, yeah. So draw a rough sketch of it. Doesn't have to be perfect. What would I scan for if I'm grading the graph? If you tell me a 0 is at -5, then what I'm going to scan for when I'm grading the graph is, does it cross at -5? So make sure it's crossed the right spots and has basically the right shape. And if you do that, you're going to be just fine. That's all you do for graphing. But there's only 2 problems with that, because that's stupid. That was a stupid section. That was the one where we had like 1 day to do the homework because it was so pointless and dumb. But that's all there is to it. So if you get a graphing one like that, it's free. You're welcome. And then you move on to the actual stuff where you're not doing it by just graphing and cheating. You're actually going to do some work and figure it out. So polynomial equations. And then we hit the section that y'all hated. And that was the one that meant use all these funky methods up here to factor things. And probably you will not fall back on difference of cubes too much, will you? Probably not sum of cubes, probably not grouping, but you should think about them in case you're in a jam. So these are useful. First off, if you can see something is written as something squared minus something squared, that's a difference of squares. And you can quickly use this formula up here to factor it. Probably more useful is the cube stuff. If you see a sum of cubes or a difference of cubes like we did in the warm-up, then these equations are great to get you started on the factoring and things like that. Honestly, you don't have to have those. And you don't have to have by grouping either. This one's another grouping one. Let's throw this one at you. So let's say I said x cubed minus 4x squared minus 16x plus 64. I give you something like this. Could you go graph it and do the whole thing that we in the next section? Yes, you could. But what might be faster, and that's really what a lot of these techniques are, is just to do it quickly. Probably faster to do it by grouping. Again, by grouping, you split into 2 even groups. You try to factor them separately. In this one, x squared goes into both. Would you concur? In the other one, I'm seeing 16. 16 does go to 64. Guess how many times? 4 times. So if I factor the negative and the 16 out, look what's left over. X minus 4. And if you can do that to force them somehow, some way to have the same thing in common, then just like anything else with factoring, the first thing you do if they have something in common is factor it out. So you could factor an x minus 4 out of all this stuff, leaving you with an x squared minus 16, and you could proceed to factor from there. Yes, ma'am? Yep. In fact, let's practice that, because this one can go a little farther. I almost thought about doing that, but then I thought, I'll just skip it. Is this a difference of squares? Is 16 something squared? Heck yeah, it is. It's 4 squared, right? So if I look at this, and I match it literally with this thing that says a squared minus b squared, I mean, you got to remember what the letters stand for. A is the number in front, right? What's the thing in front of ours? X, right? A is x. B would be 4. And I literally just changed the letters. A was x, so x plus b, which was 4, times a, which is x, minus b, which is 4 also. So we can use that equation. But do you need that equation for a quadratic? I hope not. What's another way you could have thought of this? This has no middle term, correct? Can you think of 2 numbers that multiply by negative 16 had to be 0? I can. They're 4 and negative 4. So you don't have to memorize a special formula. It's just factoring a quadratic like you always would. The one that you have to know, though, because once in a while it is the only way to do things, is things that are in a quadratic form. Once in a while, there is something thrown your way. And how can you tell if something is a quadratic form? Precisely. Exactly. Yep. Very good. First of all, it looks kind of like a quadratic. Quadratic's got 3 things, right? Something squared, something, and then a number on the end. Yes. So if you were going to factor this, I would think of this in terms of x cubes. Now, I gave you a problem that doesn't factor, because can you think of 2 numbers that multiply by 1 and add to be negative 3? I can't. But conceptually, that's how I would start it. Let me give you one where you could do it. X to the 4th plus 7x squared plus 12. Now, if you graphed this thing, you would find it has no real zeros. You'd be screwed, which is why you kind of need to know what a quadratic form is, because once in a while you do graph something and you don't have anything to start with. But I'm sure you see it, that exponent's twice that one, right? So it is a quadratic form. It's a quadratic form, just not with x's, with x squareds. So if you factor this, you would factor in the x squared stuff. And I think the two numbers that fit the bill are 3 and 4, correct? 3 times 4 is 12. And then you can proceed to solve them from here. If you solve this one, you'd get x's plus or minus square root of 3i. I won't bother going through the details. Same thing as always, set equals 0. And if you did this one, you'd get x's plus or minus 2i. And notice that all 4 are imaginary, right? So if you didn't know this was a quadratic form, you could not have got those answers, because if you graphed it, you'd have nothing to go on. There's no real zeros. You couldn't do any long division. You'd sit there and say, I can't do it, but you secretly could. So if there's one of the freak techniques to learn from the last section, I would say it's that. Quadratic forms are by far the things you probably need to do to get out of the woods in some cases. Of course, don't forget the most basic thing about factoring. If there is something in common, make sure you factor it all out first. That's the number one thing you always got to think about. All right, and that leads us to our last sections. But let's go ahead and do a problem first. Although we'll review the next section. What's the next section about? The big thing. How do you solve something in general? What do? You graph it, right? You find a 0, correct? And if you find a 0, then you got to factor, right? Don't forget that zeros are factors. If 5 is a 0, x minus 5 is a factor. If negative 8 is a 0, then x plus 8 is a factor. Do your long division, correct? And then whatever's left, work it from there, which is what we've done like 3 assignments on. So this is a very big skill. And really all I got to say about that last section, though, before we dive in, there is one more subtle thing we should review. The very last section said things like this. If you graph something and you see this, tell me what a factor is if you see it cross at -5. Great. Tell me a factor if you see it cross 6. That is great. Yes. If it bounces, don't forget it's there not once, but twice. Big thing to know, because you're looking for as many factors as you can, right? The more factors you got, the lower down you can get this thing to whittle down to. So if it bounces, make sure you are conscious that's there twice. Also, if there was some zeros, let's say we had -5 and 6, but some other jerk came along and said 2 plus 3i is also a 0, you should also know one more 0. Anybody know what it is? 2 minus 3i, outstanding. Yes, it's the conjugate. I don't even think that comes up on the test. I'm probably not going to test you over that because it's a minor thing, but just be aware of it. All right, that kind of concludes the review. Now, there's a whole bunch of problems coming up. So 18 through 28 is basically just, here's something, find the answers. So we'll do one of them. We've done a lot of these, so I don't want to do it to death. But 20 or 26, anybody want to break the tie? I heard 26 twice. We're doing 26. Here we go. Ooh, that's a good one. All right, everything I got. Graphing things, long division, sum of cubes, grouping, everything I could think of. 26 kind of starts off a little bit factored already. There's already one factor, 7x minus 1. That one's done. What to figure out what it makes it 0, but it's factored. Unfortunately, it's times this cubic thing, which has a lot of work to do. So how many answers will there be altogether? Can you tell me? There's going to be 4, exactly. 1 from this one, 3 from that one. So you better dang well have 4 slots filled out for your x equals. Well, let's see what they are. Let's get the easy one over with. Here's something, right? Don't go too fast and solve it in your head. Go off to the side for just a second. Set equal to 0. Move things around. Adding 1, you'd get 1. Dividing by 7, you'd get 1/7. There's an answer for you. Okay. So we got one of them. One of the 4 is done. The other 3 is in this one, correct? We could try to do by grouping, but what's probably even faster? What can you always fall back on? Just graph it. So let's just look at this as a separate problem. This one's already done. We already figured out what makes that 0. Here's a brand new one. Go graph that cubic and find me at least one reliable 0. Every 0 you find me, I will get this down a degree. If I can just get it down 1 degree, I can get down to a quadratic. So just the x cubed, not this thing. We're done with this thing, just that. -8 to 0. Anybody confirm? There's another one? 6 twice. It bounces? Are you sure it bounces? Okay, my last little bit of advice. Make sure, you know the zoom button? You might want to hit that. There's something that says zoom in. You might want to get really close just to quadruple check. I'm not saying you're wrong, but if you think it bounces, zoom in and really be sure that it does. It might look like it bounces, but it goes a little bit. It does. Okay, so we're good. Well, shoot, we're done then, aren't we? I mean, I could factor if I want to. X plus 8, x minus 6, another x minus 6, but there's no point because I'm just trying to find the zeros, right? And they were given to you. So actually, that was real easy. -8 and 6 are a couple other zeros. You can write the 6 twice if you want, but there's really no reason. We know it's there twice for a grand total of 4. Cool. The only last thing, look on the very last page. We'll do one of those. But the very last page is things that are completely factored, and they're asking you lots of things, zeros and multiplicity. And I'd like to go over that one more time because we talked about that in the warm-up yesterday. How to look at the degree of a factored thing and know what the leading term is and all that stuff. So I'd like to do one of these. 31 or 32? Only, well, 30 is gross too. We can do 30. Okay, let's do 30. A vote for 30. Here we go. F of x is -3, 2x plus 7, x minus 8 to the 77th, and x squared plus 1. There's benefits for things just factored like this. There's benefits for things all distributed out. What degree is this? Can you spot it? Probably not. What's the trick to figure out what the leading thing would be if I did distribute this out? Remember what it was from yesterday? Outstanding. So I'm just going to make a little note to myself right now. The leading term would be all this stuff, but just with the leading terms of each factor included. So I go through them one at a time. Here's just a number, so it's -3. Here's a factor. What's the leading term in the factor? Just 2x, right? So you keep that one. Okay, I'm going to basically ignore all the other crap except for the leading guy. So the leading guy is 2x, so I just write 2x. What's the leading person for this one? Just x. So x to the 77. And this one over here, what's the leading one in that one? X squared. So it's just times x squared. And you see you get this weird expression, but whatever it is, you clean it up. This isn't raised any power, no tricks on this one. So -3 times 2 is -6, right? How many x's you see all together? I see 1 and 77 and 2. That's a grand total of 80, would you agree? So this particular problem turns out to be an 80th degree polynomial. A lot you can tell from the leading term. Degree, 80. Leading coefficient, that's the number in front of it, which is -6.
You don't put x.
Nope, the coefficient is just the number in front of the x thing, just -6. And it's got the limit stuff. Well, that's the end behavior. What happens on the ends? This is an even degree. Even degrees open up, right? But it's got a negative, so down. So both answers are negative infinity. If you go to the left, it goes down negative infinity. If you go to the right, it goes down negative infinity. We can also say how many extrema there might be if I graph this. Remember how many extrema there are compared to the degree? The one less, so that'd be 79. And we pretty much got everything, except for the thing that says zeros and multiplicity, right? Well, that's the nice thing about it being factored. we can just go through each factor and figure out what the zeros are real quick. So I don't need this leading term stuff, but boy, that was useful for answering like what, 60% of the problem, 70%. That was very useful. Let's go through one by one, see what some zeros might be. Here's -3. When's that 0? It's not. It's -3. -3 is -3. It's not 0. This could be 0. Let's figure out when 2x plus 7 is 0. If you move the 7 over, it's -7. Divide by a 2. There's one answer. There's a 0. But it says zeros and multiplicity. Remember what multiplicity means? How many times that factor's there? Well, that factor's only there one time, correct? So you got to say that this is a 0 with a multiplicity or something of just 1. I don't care how you write it, but somehow communicate to me that that 0 is only there once. Which means on a graph, what's going to happen is they're going to go through it or they're going to bounce. It's going to go through, right? Yeah, odd ones it goes through and even ones it bounces. This one you can just spot. What makes that 0? 8. So 8's a 0. 8's an answer. And again, with a multiplicity of something, what's this multiplicity? 77. So that answer is there 77 times. A lot of zeros. The last one, well, let's see what we get from this. There should be 2 answers in this, right? It's not obvious what they are, though, is it? Well, we do what we always do. Let's set it equal to 0. Let's move the thing over. And by definition, the square root of -1 is I. So you get 2 answers there, I and -I. Just one of them. So their multiplicities are both 1. So just write that again. Both of them with a multiplicity of 1. With multiplicity of 1. And that's kind of all there is to that section. Very tedious. Are we sure we have that little trick down about finding the leading term? That worries me a little bit because we've only been talking about it this week. But again, what's the strategy to find the leading term? Ignore everybody except for the leading people, right? So ignore that, ignore this, clean it all up, and whatever it is, that would be what your leading term is if you did it. And that kind of concludes your review. So do you have any questions over any section, any questions over any problems or anything at all that you need to discuss before tomorrow? And it's okay if you do. Don't be shameful. Yes, you may. Anything at all? So a bunch of hundreds tomorrow? I'm going to get? Well, what don't you know? This is the time. Well, yeah, listen, we didn't actually graph this last one, did we? What would this thing's graph look like? Let's finish up 30 because we didn't actually do the graph. We already said it looks like an even degree pointing down, right? And you know all these zeros. So let's go find all the zeros. -7/2, wherever that is, that's -3.5, by the way. So around -3, -4, halfway in between them, something like that, there's going to be a 0. The only other 0 you're going to see is an 8. Because the other ones are imaginary, so they're not going to show up on this thing. But we know it's an even degree that opens down. So it's going to start down, come up. Should I go through this one or bounce? I should go through. Then I'm going to come back to this 8. At the 8, its multiplicity is odd. Bounce or go through. Go through again. So it almost looks like a quadratic, just straight up opening down on this one. And there's a rough sketch of it. Doesn't have to be perfect, a rough sketch. All right, that's about it. So looks like we don't have any questions. Any questions from anybody anywhere? All right, so like I said, I'll be gone tomorrow. Remote kids, I will email you the test in the morning. You need to return to me by the end of the day, Friday, 3 o'clock. Everybody else, you have 2 class periods to work on it. Tomorrow you start, and Friday I'll be back when you finish it up. And that concludes the lesson, everybody. Have a great day. One second. All right, remote kids, let me see who's here, and we'll be heading out. Got a couple chats. Let's see what's going on. Okay, Jackson's cool. How do imaginary numbers work? Have a good day. Thank you, Trevor. Macy, could you be a little more specific with how imaginary numbers work? What about them? Thank you, Adam. You have a good day too. Yes, that's cool. Madeline, Macy, Madeline, you're accounted for. That's cool. Yep, you're good, Madeline. Yep. All right, here we go. How do they behave after a number? Well, they kind of just come along for the ride. There's not much you can do with it. If you have, like, say, 5 times I, the I is a square root of -1, and the 5 is a real. They don't play it well together, so there's not really anything you can do. So if you have 5i, it just means 5 times I. It's just like 5x. You can't do anything with it because you don't know what x is. So. Cool. Anything else, anybody? All right, remote guys, you're dismissed. I'm going to go ahead and stop the lesson now.